Good morning. Today we're going to talk about sequences, and there are three types. The first type we're going to talk about is arithmetic. Here's an example of arithmetic. 2, 5, 8, 11, etc. So arithmetic sequences add and subtract the same amount every time. So add, subtract, same amount each time. There are two types of equations that you can write for sequences. One of them is called explicit, and the other one is called recursive. Explicit for arithmetic is going to take the format of y equals mx plus b. M is your rate, b is your zero term. So I'm going to have y equals, and ours is going up by 3 every time. So 3x plus, now I have to find the zero term. This is term number 1, here's 2, 3, 4, you have to find the zero term. So it's going to come before it. So if I'm going this way, I'm adding 3. To go backwards, I'm going to have to subtract 3. So 2 minus 3 is -1, so my zero term is -1. Typically, you will write this with sequence notation. So they like to use T of n to stand for y. I don't know why T, but they do. So T of n equals 3n minus 1. That is the equation for this arithmetic sequence up here. Recursive. Recursive will always have T of n plus 1 equals T of n and then plus your m value. So T of n plus 1 equals T of n plus 3. And then you have to tell them where to start. So T of number 1 was 2. You can tell them any one you want. I usually just pick T of 1. So what this is saying is, to get the next output, you take the current output and add 3. So if my output was 11, so 11 plus 3 is 14, so the next one will be 14. That's why you have to give them one to start with, otherwise they don't know what any of the numbers are. All right, the next type of sequence is geometric. Here's an example for that. 124.8, ... So geometric multiplies or divides the same amount each time. Okay, and again, two types, explicit and recursive. So explicit is y equals ab to the x, different format for geometric. A is my zero term. B is my multiplier. So y equals, we got to figure out our multiplier. So how are we getting from 100 to 20? We are dividing by 5, right? If I take 20 divided by 5, I get 4. If I take 4 divided by 5, I get 4/5, which is 0.8. That's the same as multiplying by 1/5, and they would prefer that you write it as multiply by 1/5. Again, this is spot number 1, 2, 3, 4, so I need to find the 0 spot. So if I'm dividing by 5 when I go this way, then to go backwards, I'm going to multiply by 5. So 500 times 1/5 to the x. And again, you write it with sequence notation. So T of n equals 500 times 1/5 to the n. Recursive is going to be exactly like arithmetic, except instead of adding something, you're going to multiply by something. So T of n plus 1, to get the next output, you take the current output and multiply by 1/5. Again, you need to tell them where to start. So the first term was 100. So to get the next output, you take the current output and multiply it by 1/5. 100 times 1/5 is 20. 20 times 1/5 is 4. It just keeps going like that. All right, the last one is neither. So here's an example of a sequence that is neither. And this is actually a famous sequence. It's named after a guy named Fibonacci. And you can actually Google him if you want. Fibonacci sequence. There are many other types of neither sequences. I'm just showing you one of them. And this actually does have a pattern to it, but we can't write the equation for it. So 1 plus 1 is 2. 1 and 2 is 3. 2 and 3 is 5. So it just keeps doing that. It keeps adding the prior 2. So this one here, the next term would have been 21. So that's that. These notes will help you with any homework questions that you start to see in your book about sequences. If you have any questions, just rewatch the video or ask me in class. Talk to you later. Bye-bye.